Hello students, welcome back to our channel Diksha Karnataka. So mock test 8 has been released and I hope every one of you have attempted it. So in this video, I'll be discussing the solutions of part 1, that which consists of question number 1 to question number 30. So please check your answers and if you have any doubt, you can comment. So let us see the first question. If you haven't downloaded the question paper, the link of the question paper will be there in the WhatsApp channel and the link of the WhatsApp channel will be there in the description section. So please download it and then solve if you haven't yet. Okay, so let us start with the first question. Deficiency of vitamin E causes. So this is from the biomolecules chapter. The table is there for all the deficiency disease. So the first one or the correct answer for this question will be option number C, that is muscular weakness. Next. Methyl bromide reacts with AgF to give methyl fluoride and silver bromide. This reaction is called as. So this is a name reaction from your haloalkanes chapter. So that is your Schwartz reaction, right? So the correct answer for this question is option number B. Next, the first ionization of carbon, nitrogen and oxygen respectively are. Okay, so this is important question from the classification of elements. So first let us see what is the position of this one, carbon, nitrogen and oxygen, right? They are along the period. And we know along the period what happens, along the period the ionization energy increases, right? So that means if we see, or with the expected value should be carbon, then nitrogen and then oxygen, right? This is the one which we have to be, which can be expected value. So if you check the values, then the values are your 11.3, 13.6 and 14.5. So we would have given it like 11.3, 13.6 and 14.5, right? This is what generally we would have done. But we should be careful about the electronic configuration of group 15, right? So nitrogen electronic configuration is atomic number 7, that is 1s2, 2s2 and 2p3, right? So now this 2p3 is exactly half filled, right? It is a stable electronic configuration. So you will require more energy to remove the electrons. So that is why what happens, nitrogen ionization enthalpy is the maximum. So the value here will be little different and not as expected. So here we will have a small change and the values will be 14.5 here and 13.6 here, right? So this is what you have to remember. Group 15 have a higher ionization enthalpy due to a very stable electronic configuration. So the correct answer for this question will be 11.3, 14.5 and 13.6. So correct answer is option number D. Next. The correct order of increasing the bond angles in the following triatomic species are. So we have this one NO2 plus, okay. So if you see NO2 plus is isoelectronic with carbon dioxide CO2, right? And so NO2 structure is like this. Okay, it's a linear molecule, so it is 180 degree, the highest bond angle. There is no change, so it will have the maximum value. So we can see which option. There's only one option with this one, NO2 plus. And then we have in NO2 minus, if you see, nitrogen has 6 electrons, right, in NO2 minus. So the structure is like this. So we have 6 electrons. So due to the presence of this lone pair, there will be repulsion and the bond angle here will decrease. And if you see this NO2, it is like this with 1 electron, right? So here if you compare, here there will be more repulsion. So bond angle will decrease further. So NO2 minus will be least, then NO2 and NO2 plus will be the highest bond angle with a linear shape, okay? So the correct answer for this one is isoelectronic with CO2, right? That is where the shape will be same. So the correct answer for this question is option number D. Okay. Next, highest oxidation state of manganese in fluoride is +4, but highest oxidation state in oxide is +7. This is because, so we already know +7 or the higher oxidation states are more stabilized by oxygen due to the formation of double bonds. Whereas in fluorine it is only single bond, so it is less stabilized. So the correct answer for this question is in covalent compounds, fluorine can form single bond only while oxygen forms the double bond. Okay. So the correct answer for this question is option number D. Very important point from DNF block question. Next. 142 gram of chlorine represents what? So this is again from some basic concepts of chemistry. So chlorine, you can see if it is only Cl, so it is 142 by 35.5. So somewhere it is equal to 4. Now if it is Cl2 gas, then it is 142 by 71, which is equal to 2 moles, right? So we can say 2 mole gram means 2 moles of chlorine gas or 4 moles of chlorine atoms. Both are correct. So the correct answer for this question is option number D. Very simple. Just you should know how to calculate the number of moles. Next, tertiary butyl alcohol can be prepared by the reaction of. So we have this one, tertiary butyl alcohol. Okay, we have to prepare this one. So acetaldehyde with ethyl magnesium iodide. So acetaldehyde is this one, right? And now if we treat it with ethyl magnesium bromide iodide, we will get CH3, COH and CH2, CH3, right? So this is a secondary one, right? This cannot be the answer. Next one, let us check acetone with methyl magnesium iodide. Let us check this one. If we have acetone, okay, and you treat it with methyl magnesium iodide. So this is will attack here, this one will go here. So we will get CH3, CHOH, here one CH3, sorry, here there is no H, then we have CH3, right? So this will give you a tertiary butyl alcohol. So the correct answer for this question will be option number B. I hope all are getting, I hope you have done this question correctly. Let us see the next question. The CFSE for octahedral COCl6 is 18,000. The CFSE of tetrahedral will be. So this one you have to know, delta T is equal to 4 by 9 of delta O in CFSE, right? So if I put this value, 4 by 9 of delta O is 18,000, right? So we will get around 8,000. So the correct answer for this question will be option number C. Next, an element with atomic number 106 has been discovered recently. Which one of the following is a electronic configuration that it possesses? So this one you should know. This is an exam. As seaborgium, one element is there. Okay, it's 106. The configuration for this one is 5F14, 6D5 and 7S1. Okay, the correct answer for this question is option number B. Now next question. So this one is a synthetic element. Okay. Next question. When initial concentration of a reactant is doubled in a reaction, its half-life period is not affected. The order of the reaction is. This is a very common question asked many times from kinetics. If the half-life is not affected, the rate of the reaction or the order of the reaction is always first order. So the correct answer for this question is option number A. Okay. Next. The rate constant of a first order reaction is 15 into 10 to the power of minus 3 second inverse. How long will it take from 5 gram to reach 3 gram? So first order reaction, directly formula based question from kinetics. So we can write 2.303 by K value is 15 into 10 to the power of minus 3 log of A naught by A. Okay. So if we solve this one, the answer we'll be getting is 34 point something. So the correct answer for this question will be option number A. Okay. So here you should know this log 2 to log 10. Okay, these values if you remember, you can easily solve this one. Log 5 minus log 3, we can substitute and calculate. Okay, so please check the calculation. Next question. If the threshold wavelength for the ejection of electron from metal is 330 nanometer, then work function for the photoelectric emission is. Okay, so let us see here. First of all, if we have to calculate the work function and the energy of the work function. So we have this one, E is equal to h nu 0. This one can be written by hc by lambda 0, right? So just now we can substitute the values. H value is 6.63 into 10 to the power of minus 34. C is 3 into 10 to the power of 8. And lambda 0 is 330 into 10 to the power of minus 9. Okay. So just do this calculation. This is a simple calculation. If you get this, you will be getting answer around 6 into 10 to the power of minus 19 joules. Okay, the correct answer for this question is option number C. So this is simple calculation I am not doing. You have to do the calculation and check whether you are getting this answer or not. Okay. Next, what will be the EMF of the following concentration cell? Very, very important term, concentration cell. You have to remember for any concentration cell, E naught of the cell is always equal to 0, right? Now let us see. Ag to AgNO3, so suppose this is one reaction, this is anode side, right? So I'll first write anode reaction. Ag from solid is getting converted to Ag plus, that is oxidation. What is the concentration here? 0.01. Now what will be the reaction at cathode? Right, cathode, you see Ag plus is getting converted to Ag, so we will have Ag plus getting converted to Ag. Here what is the concentration of Ag plus? That is 0.05 molar. Okay, now if we add these both reaction, this one will be getting cancelled. I'll get Ag plus 0.05 to Ag plus 0.01. Okay, so the point of writing this one is you should clearly know which ion is or which concentration is coming on the product side and which concentration is coming on the reactant side, because in Nernst equation we have that product by reactant, right? So that is why we should write this reaction to remember that one. So now I can calculate E of the cell will be equal to minus 0.059 by N. N value I can take for silver, it is 1. So N value is 1 log of 0.01 by 0.05. So I can write minus 0.06 for easy calculation log of 1 by 5, right? So if we solve this one, the correct answer for this question you will be getting around is 0.04. Okay, so the correct answer for this question is option number B. Okay, next question. Which of the following compounds does not react with NaHSO3? Okay, so you can see the options. First of all, if the options are all aldehydes and ketones, right? We know aldehydes are more reactive than ketones. So that is why I can eliminate these option. Now here there are two ketones, right? Now if you check the structure of this one, C6H5COCH3, and here we have CH3CO CH3, right? Now what is the difference here? See, the reactivity will depend on the electrophilicity of this carbon, right? Now what happens here, due to resonance, the electrophilicity of this carbon is reduced, so its reactivity is reduced. So the correct answer for this question will be option number B. Okay, so aromatic ketones will be less reactive because of reduced electrophilicity of the carbonyl carbon. Now let us see the next question. A certain current liberates 0.504 gram of hydrogen gas in 2 hours. How many gram of copper can be liberated by the same current flowing for the same time in the copper sulfate solution? Okay, so here one thing we can remember, the formula we have is M1 by M2, okay, is equal to E1 by E2. This is according to Faraday's second law, right? Now I want to calculate, so let M1 be the mass of copper deposited, let M2 be the mass of hydrogen deposited, let E1 is the equivalent weight of copper and E2 is the equivalent weight of hydrogen, right? So now let us substitute. So this value I have to calculate. M2 is how much? What is the mass of hydrogen deposited? 0.504 gram. Then equivalent weight of copper will be, we can see molar mass of copper is 63.5 divided by N factor, that is 2, right? Molar mass by N factor is equivalent weight. Then hydrogen equivalent weight is 2 by 2, right? Because the reaction is what? 2H plus 2 electrons gives H2, right? So molar mass is 2 gram, number of electrons is 2. So I can write the equivalent weight of H2 is 1. So I can substitute here 1, right? So now if we solve this, we can get M1 value, that is 63.5 by 2 into 0.504, right? So if you solve this, the correct answer for this question will be somewhere around 16, okay? So you can see here it will be some 30, we can just imagine something around 32 will be coming, and 32 into half multiplied with half will be somewhere around 16, right? So the correct answer for this question is option number B. Okay, next. So solutions, we came to solutions chapter. Osmotic pressure of a solution containing 2 gram dissolved protein for 300 ml of the solution in 20 mm of Sg at 27 degrees Celsius. The molecular mass of the protein is. So osmotic pressure formula we know, pi is equal to CRT W2 by M2 into 1000 by volume in ml into R into T, right? So what is the mass given? W2 is 2 gram, okay. M2 we have to calculate into 1000 by volume is 300, okay. Now R is 0.08 21, and temperature is given to you 27. 27 plus 273 is 300. Okay. Now what is the osmotic pressure given to us? Osmotic pressure is 20 mm of Sg. Okay. Okay. Here one thing is there that we have to convert it into ATM, because you see here the unit is liter ATM, mole inverse, Kelvin inverse. Now we can convert this one. So we know in 760 mm of Sg, okay, that is 1 ATM, right? That means in 20 mm of Sg it is 20 by 760 ATM. So here we'll put 20 by 760 ATM, right? So this part, let me write little clearly here. So here we have 20 by 760 ATM. Okay, so we'll get 20 by 760 ATM is the osmotic pressure. Then we have to calculate M2. So if you calculate this one, the M2 answer will be somewhere around 6000. Okay, so the correct answer for this question will be option number A. Okay, please check the calculation. You have to do the calculation, nothing there. This normal multiplication division you have to do and check the calculation. Next. Which of the following polymers is stored in the liver of animals? That is from your biomolecules. We know glycogen. Correct answer for this question is option number D. Next, aniline when diazotized in cold and then treated with N and dimethyl aniline gives a colored product. The structure of this product is. So if you remember, this is a coupling reaction. So first of all, we have one side is aniline. Okay, aniline when diazotized with cold. So we have first diazotization. Okay, now this one is treated with N and dimethyl aniline. So this one is treated with N and dimethyl aniline, right? So this side coupling will take place from here to here, right? So we will get the product as, you can see this one will be the product. You can see the two groups are here, then the benzene ring, then the diazotium salt, and then the another benzene ring. So the correct answer for this question will be option number B. Okay, so this question is little tricky, but if we have already have two coupling reactions in the NCERT book, so if you know that, this is very simple one, right? Okay, next, consider the following compound. So we have one substitution in the ortho position, another substitution at the para position. Okay, the vapor pressure of the compound 1 at a given temperature would be expected to be. Okay, so now you see here vapor pressure depends on what? So if intermolecular forces, okay, is weak, right? If the intermolecular forces are weak, then the molecules can easily go to the vapor phase. That means vapor pressure will increase, right? Now if it is opposite, if the intermolecular forces are very strong or the packaging is very strong, then they cannot go to the vapor phase easily and the vapor pressure will decrease. Now we know para has a symmetric organization or symmetric molecule, so it is tightly packed. So it is difficult for the para molecule to go to the vapor phase easily as compared to the ortho molecule, right? So that is why what I can say is the one which is ortho can easily vaporize. Okay, can easily vaporize. So if it can vaporize easily, then what will happen? Vapor pressure will be more. So the vapor pressure of 1, so let us see the vapor pressure of compound 1 will be higher than that of 2, right? So the correct answer for this question is option number B. Okay, next, the color of the coordination compound depends on the crystal field splitting. What will be the correct order of absorption of wavelength of light in the visible region for the complexes? Okay, so we have these 3 complexes, right? This is little thing that we have to understand. If the ligand is a strong field ligand, okay, if we have a strong field ligand, then what will happen? It will have more splitting. Okay, more splitting will be there. More splitting means that is high energy is required, right? If high energy is required, then less wavelength. Wavelength will be very small, right? Now it is also opposite. If it is a weak field ligand, so just opposite will happen. If it is a weak field ligand, then what will happen about the splitting? Splitting will be less splitting. If less splitting, then it is less energy. If less energy, then it is more of wavelength or larger wavelength, right? So now what we have to do? we have to arrange in the order, right? So which one will be absorbing the maximum wavelength, where the field, where the ligand is a weak field ligand, their splitting will be less, energy required will be less, so the wavelength will be maximum. So if you compare, the ligand strength is like this. Okay, water is the weakest ligand, right, in out of these three. So that means water will have less splitting, less energy and more wavelength. So that is why water will have more wavelength. Okay, so all other options are different, then NH3 and then Cn. So the correct answer for this question is option number C. Okay, next. When 100 gram of water is electrolyzed at constant pressure of 1 atmosphere and temperature of 25 degrees Celsius, the work of expansion is. Okay, this question is from your thermodynamics. Okay, important one, easy one, but we have to understand a little bit what is happening. See here, there is water. Okay, now water has, when it has become electrolyzed, when we electrolyze the water, H2 gas and O2 gases are produced. Now, due to the production of these gases, what will happen? Volume will change or the volume will increase. So now we have to calculate the work done here. We know work done is P external into change in volume, right? So first of all, we have to calculate what is the change in volume due to the production of these gases, right? Now, how to calculate that? So it is very important question. See here, if this is the general equation, I can say 2 moles of water. 2 moles of water is giving me 3 moles of gas, right? In this 3 moles, 2 moles is H2 and 1 mole is O2. So 2 moles of water, I can write it as 36 gram, right? 18 is 1 mole, so 36 gram is giving us 3 moles of gases, right? Then 1 gram will give me how much? And we have taken how much? 100 gram of water. So 100 gram will give us 3 by 36 into 100. So that will be coming around 8.33 moles, right? So the total moles of gases produced is 8.33 moles. We have still not reached the answer because we need the volume, but we just now calculated how much moles have been produced. So now we can convert it into volume. So you can see this, like assuming that it is an ideal gas, we can use volume is equal to nRT by P, right? N is your 8.33 moles. What is the number of moles of gases produced? That is 8.33. This is 0.0821. Temperature is 25 degrees Celsius, so 298 Kelvin. Then pressure given is 180. Okay. So if we solve this, right, you will getting around 203.8 liter. Okay. Now we can put this in this value and we'll check here. So minus 1 atm into 203.8 liter. But you see the options are in joules, right? So we must convert it into joules. So to convert this one into joules, we should multiply with 101.3 joules. So after solving this, the answer will be getting around is 20.6 kilojoules. So the correct answer for this question is option number B. Once again, I'll explain this question, little difficult one. First of all, you should know so what is the question actually asking? When liquid water was there, when electrolysis happened, we got some gases produced like hydrogen and oxygen. So due to this gases, volume will change. So what is the work done in that case? So first of all, we have to calculate how much this H2 and O2 is produced. That we can do using this normal stoichiometry method. After getting the moles of H2 and O2 produced, we can convert it what is the volume occupied by these gases. So after getting the volume occupied, then we can calculate the work done, P external into dV. Just calculate the work done and then multiply it with joules to get you this value. Okay. So please check this question. If you have any doubt, comment down. I'll explain again. But this is very simple one. Just we have to identify how is this part related to volume. Okay. Fine. Next question. A gaseous carbon compound is soluble in dilute HCl. The solution on treating with Na, Na2 and HCl gives the nitrogen, leaving behind a solution which gives a smell of wood spirit. So we know wood spirit is generally methanol, right? So the carbon compound is. So the point here is what will give you methanol. So if you see CH3NH2, very direct question, when treated with nitric acid. Okay. For aliphatic amines, if you remember, NH2 on HNO2 will give you alcohols. So we will get CH3OH. So the correct answer for this question is option number B. Okay, next. So now let us see the next question. For the reaction A plus B products, what will be the order of the reaction with respect to A and B? Okay, so here this type of questions are very common in chemical kinetics. So first of all, you have to take those reactions where one of the concentration is taken to be constant. So you can see in reaction 2 and reaction 3, concentration of B is constant, right? So let us take these two reactions. First of all, we have, let us write a general equation. R is equal to K into A to the power of X and B to the power of Y, right? So first I will write R2 and R3. So what is the value of R2? 4 into 10 to the power of minus 3, okay, is equal to K into 5 into 10 to the power of minus 4 to the power of X and 6 into 10 to the power of minus 5 to the power of Y, right? Now let us see the next one. 1.6 into 10 to the power of minus 2 is equal to K into 1 into 10 to the power of minus 3 to the power of X and 6 into 10 to the power of minus 5 to the power of Y, okay. So now just what we can do is, if we divide these two equations, we will get 4 into 10 to the power of minus 3 by 1.6 into 10 to the power of minus 2 is equal to 5 into 10 to the power of minus 4 by 10 to the power of minus 3 whole divided by X, okay. So now if you solve this, we'll get this one will be coming around, so we can write 4 by 1.6 into 10 to the power of minus 1, so that is 0.4 by 1.6, so that is your 1 by 4, right? This side is 1 by 4 is equal to, we have here 0.5 to the power of X, okay. So now if you solve this, we will get X value as equal to 1, right? So one value you can write 0.25, so 0.25 will be okay, let us solve it. We'll get 0.25 is equal to 0.5 to the power of X. This one I can write it as 0.5 square is equal to 0.5 to the power of X, right? Okay, so we will get here X value is equal to 2. Sorry, this part is incorrect. X value we will get as 2, right? So the, what I can say, the order with respect to A is 2. So you can see we can eliminate option A and option C, right? It can be either B or either D. So this is the part of solving for A part. Now let us go to the B part. Okay. Now if you see the, so here I will write the result here, X is equal to 2. Now if you see here, we can take any reaction here. Let us take these two reactions. So 2.5 into 10 to the power of minus 4 to the power of X into 3 into 10 to the power of minus 5 to the power of Y is equal to 5 into 10 to the power of minus 4. This is the first equation. Second equation I can write is 5 into 10 to the power of minus 4 to the power of X into 6 into 10 to the power of minus 5 to the power of Y is equal to 4 into 10 to the power of minus 3, right? So now if we solve this, just divide this both equation, substitute the value of X here. So Y value we will be getting is 1, right? So just very simple, just divide two equations, you solve it. So the correct answer for this question is 2 with respect to A and 1 with respect to B. Already I have solved the first part, just substitute it and solve the second part. The correct answer for this question will be option number B. Next, which compound will not reduce the Fehling solution? So we know aromatic aldehydes do not reduce your Fehling solution. So benzaldehyde is an aromatic aldehyde. So correct answer for this question is option number D. Next, the equilibrium constant Kp for the reaction PCl5 gives PCl3 plus Cl2 is 1.6. The pressure at which PCl5 will be 50% dissociated at 200 degrees Celsius is. Okay, this is very important question. So please understand this question. We have this one. Okay. Now what is done here? The pressure, let the pressure initially be 1. Okay. At that time this one will be not there. So 0, 0. Okay. Now after certain time 50% has dissociated. Means how much will be left? 1 minus 0.5. How much dissociated? Same amount of PCl3 and Cl2 will form. So this is also 0.5 and this is also 0.5. So this is equal to 0.5, right? Now what is the total number of moles? N total is 1.5, right? Now we can calculate the partial pressure of each of them. So what is the formula of partial pressure? partial pressure is mole fraction into P total, right? So now we can calculate the partial pressure of PCl5 is equal to how much? Mole fraction is 0.5 by 1.5, that is number of moles by the total number of moles into P total. Similarly, if we have the partial pressure of PCl3, that is also 0.5 by 1.5 into P total, and same is for the pressure of P of Cl2, right? Now we can write the expression for Kp. So what is the expression for Kp here? Kp will be equal to partial pressure of PCl3 into partial pressure of Cl2 into partial pressure of PCl5, right? So now if we substitute these all values, we'll get 0.5 by 1.5 into P total, right? So this is equal to 1 by 3 of P total. Now Kp value is already given in the question as 1.6. So what is the total pressure? Total pressure will be 4.8. So the correct answer for this question will be option number B. Okay, next question. The hybridization state of the central atom and shape of the molecules is given below. So mark the incorrect combination. So this one is from the Vesper theory. You should know all the numbers, their geometry, shape, hybridization and everything. So SO3 is sp2, that is correct. SO2 is sp2, that is also correct. H2SO4, if you see, that is SO4 2 minus, right? So this is actually sp3 hybridized and tetrahedral shape, right? So but the option given here is sp2 hybridized. So the incorrect combination is option number C. Okay. Next question. Actinoids in general shows more oxidation states than lanthanoids. Okay. So this is because of less energy difference between the 5f orbitals and 6d orbitals. More electrons can participate in the bond formation. That is why we get this variable oxidation state. So the correct answer for this question is option number B. Okay, next. Standard enthalpies of formation of O3, CO2, NH3 and HI are given. So let us first list down these data. O3 formation is 142.2. CO2 is minus 393.3. Then we have NH3, which is minus 46.2. And then we have HI, okay, which is plus 25.9, right? Now you have to understand here, whenever there is formation, energy is released, right? So more the energy is released, more is the stable compound. So if you check all these options, CO2 in that case 393 energy is released. This minus symbolizes that the energy has been released in the process. So CO2 is the most stable compound. So if you see all the options, then option C will be the correct because CO2 is most stable. Then in this NH3 46.2 energy is released. So then NH3 will come. Now in these two cases, what has happened? Energy has to be provided to for the formation of these two. So O3 more energy is provided. So that is more unstable. So the least will be O3 and then will be HI. So the correct answer for this question will be option number C. Okay, next. Alkyl halides are immiscible in water, though they are polar. So whenever there is miscibility with water, it is the hydrogen bonding. So we know that they cannot form hydrogen bonds with water, so they will not be soluble in water. So the correct answer for this question will be option number B. Next question. The Van 't Hoff factor of 0.005 molar aqueous solution of KCl is 1.95. The degree of ionization of KCl is. So first of all, we have to understand whether it is association or dissociation. KCl dissociates to give you K plus and Cl minus. So we have this formula alpha for dissociation as I minus 1 by n minus 1. Okay. So we have to calculate the Van 't Hoff factor. So you have to calculate the I value. So alpha for dissociation is given to you as 1.95. The Van 't Hoff factor of the solution, the Van 't Hoff factor is given to you as 1.95 minus 1. N value is the number of ions produced after dissociation. So we have 2 ions produced, so N value is 2 minus 1. So just calculate this one, we will get alpha of dissociation as 0.95. Okay. So the correct answer for this question will be option number A. These were the first 30 questions of the mock test 8. So please solve it, check your answers. If you have any doubt, please comment. I'll be addressing it in the next video. If you have found this video useful, please like, share and subscribe the channel. Thank you.